Hi guys, welcome to your second set of notes for course readiness. If I did not explain this earlier, we're just reviewing really quickly some commonly missed errors that you guys usually complete in course readiness, just a little bit of algebra review before we start into chapter 1. So all of this stuff that I've been doing in the last set of notes and this set of notes for today, which are your square roots, should all be something you guys already know. It's just a quick review so we're all on the same page before we start the content in Algebra 2 Trig. So in our warm-up today, what I want to go over real quickly, I'm going to do half of the warm-up with you and then I'll let you guys do the rest of it by yourself before we get into the lesson. But what I want to go over is the difference between a least common multiple and a greatest common factor. They're two completely different things, and we're going to need to know the difference with them in Algebra 2 Trig when we start actually learning the content. So just as a quick review, GCF is greatest common factor and LCM is least common multiple. Okay, so let's just do a quick example like of easy numbers. Let's say the GCF and LCM of 4 and 6. Okay, let's do the GCF first. In math, and I'll say this several times in this year, we are not creative with naming things. So greatest common factor is exactly what it says. The greatest factor that they have in common. Okay, so factors are things that go into these numbers. So if you factor 4, you get 1, 2, and 4. If you factor 6, 1, 2, 3, and 6. What is the greatest common one they share? 2. That's your GCF. So when we get to factoring and everything, you would take out a 2. That's when that comes in handy. LCM is the least common multiple. So you do the multiples of these numbers and find the least common one they have. So for example, you just list the multiples. So for 8, 12, 16, 20, blah, blah, blah. You could go for forever if you want to. 6, you do the same thing. 6, 12, 18, 24, and it goes on as we know. So you find the common ones they have, and you find the number that's the least of them. So the least common multiple for 4 and 6 is 12. So again, two completely different numbers, so please understand the difference between those two. So obviously this is like an easy way to do this if you have smaller numbers like 4 and 6, but we're stepping up into Algebra 2. We're going to have bigger numbers, and listing all the factors. For example, if we're going to do 60 and 42, that's going to take, especially the LCM part, that's going to take a lot of work, and that's going to be pretty annoying to do. So I'm going to show you a quick trick if you get these higher numbers, just to make your life a little bit easier. So we're going to do the GCF and LCM of 60 and 42. So what I want you guys to do when you get these problems, just create like a little L. It's kind of like a division symbol, because what we're going to do now is factor. So try to think of something that goes into 60 and 42. There's obviously several things that they both have in common. I'm just going to first take out like the smallest number I could think of, 2. Okay, that's probably the first thing that came to mind for most of you guys. So 2, and 2 goes into 60 30 times, 2 goes into 42 21 times. Okay, do we do the same thing? What goes into 30 and 21? Immediately I think of 3. Okay, so 3 goes into 30 10 times, 3 goes into 21 7 times. Then you try to repeat the process until you're at two numbers that don't share a common factor, like 10 and 7. Okay, so now we have all the information we need to find our GCF and LCM. So for GCF, you just look at the left side of that division symbol. So I like to make like a G, like this, to remind myself it's GCF, and you just multiply those two numbers, 6. And then for LCM, I take all the numbers by making a like bubble letter L, as you can see here. And we multiply all those numbers, 2, 3, 10, and 7. Multiply those all out, you would get 420. Which would be a lot of work if you had to multiply or do multiples of 60 and 42. So quickly, I found the GCF, and quickly I found the LCM of two big numbers. Okay, so let's practice that with 1 and 2 real quick before I let you guys go. So again, you could probably do some of this in your head with the smaller numbers like these, but I just wanted to show you that trick above with some of the bigger numbers. So 12 and 15, first thing I think about is 3. So you get left with 4 and you're left with 5. Those have nothing in common. So the GCF is just the left side, and the LCM is all those numbers multiplied, which would be 60. Okay, for 7 and 21, what goes into 7 and 21 is 7. Then I'm left with 1 and 3. So my GCF is 7 and my LCM is 21. So I wanted to show you this one to show you that, yes, the numbers in the problem, like 7 and 21, can be your answers as well. So that is allowed. So don't get worried if you get those type of answers. So I want you to pause here, do 3, 4, 5, and 6 by yourself, and then come and check back for your answer. All right, so again, I'm just quickly going over like the items you see in course readiness. All should be reviewed. I just want to go over like the ones that most people commonly miss. So I'm going to keep on going over PEMDAS. I know you're going to be like, this is so elementary. It's really not, because so many of you guys mess up the littlest mistakes, and that's what kills people a lot on your tests in this class, is the tiny, tiny, tiny algebra mistakes. So you really need to be particular in this class. So first one is 5. Number 4 is 28. Number 5 is negative 54. So what I was showing you here is that if you're someone who keeps on messing up your symbols, you just are messing up somehow, I like to underline. I use PEMDAS, obviously. That's how we should all be doing it. But I underline what I should be doing first. So like for the number 3, the first thing you should be doing is division. So I just underline that section of the problem I'm doing just to concentrate more on what exactly I'm doing. So those of you guys who need the extra help, please start just going slowly, step by step. Number 6 is always like a topic that people need to do and they get confused on. It's just naming your coordinate grid. You learn this in Algebra 1 or in middle school. So you always start at 1 here and then you go around the clock. Okay, so that's kind of just reviews quick topics. Now we're going to go into the bulk of the lesson. The bulk of the lesson today is simplifying square roots. So you obviously learned this in Algebra 1. You quickly went over it in some type of topics in geometry. And then we're just going to go over it more here because it is a very necessary thing to know in this class. So you might have learned square roots completely different than I'm going to teach it. I'm going to show you this way. Many students will gravitate towards this way anyways, but it helps with as we get into higher roots, because in this course we're going to get into things like not just square roots, we're going to get into like the 3rd root, the 4th root, things like this. And what I'm going to show you right now is going to lend itself to when we learn those harder topics. So what I do is that I make factor trees. So you always want to kind of think of low numbers like your 2, 3, 5 that go into these types of numbers. So I'm going to start with 2. So 2 goes into 50 25 times, and then 25 can be split up into 5 and 5. So after you have your factor tree done, what you want to do is find your friends. So you find pairs of numbers together. Okay, so for example, 5s are friends, and you have friends, you get to play outside. But if you're a little lonely person and you have no friends like 2 has to stay inside the house. So that's your final answer, 5 rad 2. Number 2, 175. So again, you think of low numbers. So what I'm going to think of here is 5. 5 goes into 175 35 times. 35 can be split up into 5 and 7. So you're always looking at you're like, what numbers am I looking at? You're looking at like the end of your branches. You're looking at 5, you're looking at another 5 and 7. So again, we want to find our friends, because if you have a friend, you get to play outside. But if you're a lonely person, you have to stay inside. So 5 rad 7 is your final answer. We'll do one more before we start doing computations with these. So 124, I always like to start with 2 if I can. 2, 62, 2 goes into 62 31 times. 31 cannot be broken up anymore, so 2s are your friends. They get to play outside, and 31 stays inside. Okay, so that's just if you have numbers. You guys should be pretty good at that. Then we're going to quickly go over if they have variables inside your square roots. So this is where you guys are going to get confused. Numbers and variables are totally different. So if you have a number and a variable, just do the normal thing what you're doing above with the numbers. So you're going to do like your factor trees with these numbers. The variables have different rules. So that's where people usually mess up. And I'll show you when we're doing the problems where you in particularly mess up. All right, so the rule is this. If the exponent is even, just simply divide by 2. How easy is that? So if you have x to the 16th, the square root of that is just x to the 8th. Just divide by 2. The issue is if your exponent is odd. We can't divide an odd number by 2 because we're going to get a fraction, and that's not something we're going to be doing in this class. So what you want to do is just make that odd number into an even number. So I'll show you when we're doing this problem. It's probably easier for me to do it than to explain it. So again, you treat your number different than your variable. So we just do the square root of 4. Square root of 4 is 2, so we don't have to do a factor tree for that. And then x to the 8th is an even number. Divide 8 by 2, 2x to the 4th. Number 2, 16 y to the 9th. So again, let's do the 16 part first, the coefficient. Square root of 16, 4, again, just as a perfect square, we're just quickly doing this. So the y to the 9th is giving us our issue. We can't divide 9 by 2. So what we're going to do instead is break 9 up into using our exponent rules. You can break it up into y to the 8th times y to the 1st, right? Because 8 plus 1 is 9. So we're still at y to the 9th. We didn't change the value of the problem. We just broke it down. So now I'm going to be able to take y to the 8th out of the little house by dividing by 2. So it becomes y to the 4th. And then the y to the 1st just has to stay on the inside. So 4y to the 4th times the square root of y is your final answer. All right, now we're putting everything together. So square root of 32 is not a perfect square, so we're just going to do our factor tree now. So 2 and 16. And here's what I wanted to show you. So you guys are gonna have different factor trees just depending on how you like to factor. So some people might from here go 2 and 8 and then keep on going down all the way the factor tree. If you see and notice a perfect square already, so I noticed that 16 is a perfect square, I'm just gonna split up into 4 and 4. That way I quickly get to my pair of friends. You're gonna get that eventually if you did the 2 and 8, then 2 and 4, and you went down the factor tree, you'd be getting the same answer. But I'd like to show you if you quickly see or notice it's a perfect square like 16, just already have its 2 friends ready to go, and then you can start your problem. So I'm gonna do 4. On the inside will be 2. I'm leaving some space here because of the variable that we're gonna have, so that's why it looks weird for right now. So we have 4 rad 2 for the number part. For the x to the 11th part, again, we need to split up 11 using our exponent rules. So x to the 10th times x to the 1st is still the value of 11, so we haven't changed it. I can take the 10 out by dividing by 2, so x to the 5th on the outside, and then the lonely x stays on the inside. So that is your final answer. So above, when I was warning you guys not to treat the coefficient and the variables differently, this is what I mean. So many people get so in the habit of dividing by 2 in their head that they now treat this by dividing by 2. So many people will go like this. Instead of like the 4 on the outside and like the 2 on the inside, they'll think the answer instead is divide 32 by 2, so it's 16 on the outside, x to the 5th, square root of x. Okay, that's what I mean by being careful. Treat the coefficient, treat the variable separately. So you're not dividing the number by 2, you're dividing the variable and the exponent by 2. So be very careful if you're one of those people who make careless errors. All right, now that we know how to simplify radicals, now we're going to add, subtract, multiply, and divide them, and then we'll be done. So we're gonna add and subtract square roots. You can only add and subtract square roots if they have the same thing underneath the radical. So 32 and 98 are obviously 2 separate numbers. We can't add those together, so we're going to simplify them first to see if that will work out. So we're going to do our factor tree. My hint here is that if there's a coefficient in front of your radical already, for example, 2 is, circle that already. It's already a friend. Okay, and it's a lonely friend. So 2 is already on the outside. I'll show you guys why I circle it because people forget about it. Like I've made several mistakes in my math career where I forget about that first number and messes you guys up. So I like to circle it to remind myself. So 2 and 16, again, I recognize 16 is a perfect square, so let's already have our friends out. 4. So typically, if you ignored, for example, this 2, it would be 4 rad 2. But the reason I circle this 2 in the front is to remind myself there's already a 2 there. So I have to multiply whatever I get in the outside number by 2. So it's 4 times 2, which would be 8. So that's what my final answer for that first portion is. Now we're going to do the same thing with 98. So there's nothing in the front, so we don't have to worry about anything sneaking by. So 2 and 49, 7 and 7. So 7 on the outside, 2 on the inside, and we are adding these two together. So now they both have radical 2 on the inside. Now we're able to add these two together. So just think of it as a variable. If this was like 8x plus 7x, you would say this is 15x, right? But instead of having x's, they just have the same radical. So it's just 15, and you don't add this to make it like square root of 4. You just leave it as 15 rad 2 as your final answer. All right, number 2. So there is a coefficient on the outside, it's -1, so whatever we get, we're going to multiply it by -1. Okay, so 48, split it up into 2 and 24, 2 and 12, and keep on going, 2 and 6, 2 and 3. So we haven't dealt with this yet, and the reason I picked this question is for a reason. So you have 2 sets of friends. You have this group of friends, and we have this group of friends. Okay, so what do you do when you have multiple groups of friends? You multiply them. So we have a group of 2 times a group of 2 times -1. So the outside number is -4. And then what's left inside is your lonely 3. Okay, now we do the 2 rad 27. So 2, you have to remember to multiply that at the end. So you have 3 and 9, 3 and 3. And some of you guys do like very specific questions like, which group of 3s do I circle? It doesn't matter as long as you have a group of 3. I don't care if you do this. I don't care if you do this. As long as you have a group and you know which one's lonely, I don't really care. Okay, so you have a group of 3 times the original 2. That leaves 6 on the outside and lonely 3 on the inside. And would you look at that? They both have rad 3 on the inside. That means you can actually add these outside numbers together. So -4 and 6 add up to 2, and then you have radical 3. So pause here and try number 3 all by yourself, and then continue on once you have your final answer. All right, number 3, you should have gotten 26 rad 2 as your final answer. Okay, so that is adding and subtracting. I know we technically didn't do subtraction unless you count number 2 as subtraction because of the -4, but it would be the same idea if you were subtracting the numbers and versus adding. Okay, now we're going to multiply radicals together, and it's a little bit of a different rule, but you're always going to start out by simplifying your radicals first. So what you can do actually with multiplication, but you would never do it with these types of problems, with multiplication, you can start off the problem by multiplying these numbers together, 50 and 18, and then you get some big, huge, number, and then you're going to do this tree with it. Obviously, that would cause a lot of problems, but you can multiply any square roots. Unlike when we were up here, we can't add, for example, 32 and 98. They have to be the same thing. With multiplication, they don't have to be the same thing. You can already go from it. So just a quick note on that. All right, but like I said, we're going to always start with simplifying to make our lives a little bit easier. So 2 is on the outside. You have 2 and 25. And then 5 and 5. Okay, so we're going to have 10 rad 2 for simplifying. We're going to do the 18, 2 and 9. So now I'm going a little bit faster simplifying because we should be good at simplifying by now. We're just going to concentrate on how do you multiply radicals. Okay, so like I said, multiplication rules are different. So we're going to treat the inside and outside numbers separately. So you do 10 times 3, which is 30. In the adding and subtracting, we did not touch the rad 2, like they stayed the same. That is different with multiplication. With multiplication, you do actually multiply those two numbers together. So 2 times 2 is 4. We can actually simplify this. Square root of 4 is 2, so we can keep on going to get 60 as our final answer. And what I wanted to point out here is that, like I said before we started the problem, the numbers on the inside of the radical do not have to be the same. So we could have continued on. Let's pretend the inside of this was 3. We would be able to still continue on with the problem. We would just do 3 times 2 is 6, and then we would keep on going, for example. So it doesn't have to be the same thing underneath the radical. It just happened to be on this sample problem. It does not have to be. Unlike, again, above, it has to be the same thing underneath to continue on. And by the way, because it didn't happen, again, let's pretend it wasn't the same underneath. Let's pretend it was, for example, a 3. Then this would be just your final answer. Because if they're not the same underneath, then you don't move on. That is it. Okay? So trying to show you everything you might come across so you do not get confused. All right, number 2. So square root of 24, again, you mix it up. Oh, here's what I also want to show you. I don't like if you guys do it, so I like to start by 2s, like I said, because it makes like a nice, clean factor tree that I can easily see what's going on. That's why I like to start with the low numbers 2 and 3, like I told you guys at the beginning. When people do, for example, they might do like 4 and 6, and then you have to split up 4, and then you have to split up 6, or it makes sometimes like an uglier tree as you guys like start splitting up in like completely different branches. So that's why I like to just use small numbers, because I could see like an easier tree that just goes down on the right-hand side. But whatever is comfortable to you, but that's why I don't split things up into like 8 and 3 and 6 and 4, something like that. So I like to go by 2s. All right, 2s on the outside, and we actually have 2 lonely things on the inside. So in that case, we always multiply those factors together. So on the inside would be 6. Then with 96, we have the original 3. This is 2 and 48. And we're going to have a long tree here. 2 and 24, 2 and 12, 2 and 6, 2 and 3. So this would have been like a really ugly one if you started, for example, sprouting 48 different and like got like a huge tree. So I just have to make like a simple tree like this. Okay, we have several pairs of friends. We have 2, and then we have 2 left over. Okay, so we do 2 times, so we do 2 times 2 times the original 3 to get the outside number of 12. And then on the inside would be 6. Again, it doesn't have to be the same on the inside. It happens to be like that this time. Regardless if it was or wasn't, you just continue moving on with multiplying. So we multiply the outside numbers together, which would be 24. Inside numbers together would be 36. And we can always simplify. So 24 times 6 is 144. So you get a whole number on that one. All right, number 3, one more before I let you guys do one by yourself. Original 2, 45 is 5 and 9. So our outside number here is 6. With 72, we have 2 and 36. Again, I recognize that's 6 and 6, so I don't have to do like a super long tree. You get the same answer, but I want to make my work as short as possible. So here's a good one. We don't have the same thing underneath the radical. It's okay, we can still move on. Again, if this was a plus sign, that would just be a final answer. We're done here because 5 and 2 are different. But with multiplication, you can move on. So 6 times 6 is 36 on the outside. 5 times 2 on the inside is 10. That's as far as we can go because we can't simplify 10. So that is your final answer. So try number 4 all by yourself and then return back for the answer. All right, number 4, you should get 60 as your final answer. So we did add, subtract, multiply. So you know what's next. We're going to divide, also known as rationalizing the denominator. That's the verbiage we use mathematically for this. So again, we should remember that you can't have a radical on the bottom. That's not simplified. So if you ever gave this to me as an answer on a test, you would be wrong. So make sure you guys clear radicals on the bottom. And how you do that is that you multiply the top and bottom by whatever's on the bottom. I'll correct that. Not what's on the bottom, by the radical on the bottom. So if you had like a 4 here, so it was a 4 rad 3, you're not multiplying by 4 rad 3, you're just multiplying by the radical part, because that's the part that we want to get rid of. So just the radical part you multiply by. So you multiply fractions, of course, across. So we do the numerators, 10 rad 3. Rad 3 times rad 3 is rad 9. So you simplify and get 3 on the bottom. So many of you guys can skip this step, because I hope that you guys know that a radical times itself is just itself without the radical symbol. So most of you guys can skip that middle step. And then what I want to also show you is that you guys get super excited about crossing things off and simplifying, but sometimes you guys are a little bit too eager and you're wrong. A lot of you want to go like this and just say like the answer is 10. You can't do that. This 3 is an outside number, I'll call it, and this 3 is an inside number inside the radical. You cannot simplify numbers that are different. If they both were underneath the radical, you can do that. If they both were on the outside, you can do that. So for example, if this 3 on the bottom was 2, 10 and 2 are outside numbers, and you could have simplified that. But if they are inside versus outside numbers, please do not simplify them. All right, number 2, 14 and rad 21. Okay, so let's do rad 21, rad 21. Just kidding, that would be terrible, right? So what I want you to notice is that they're both underneath the radical. Okay, so if they're both underneath the radical, let's just simplify that. So square root of 14 and 21 have 3 in common. Sorry, 7 and a higher number. So I can actually reduce this to a new problem. Divide each of those numbers by 7. We'll get square root of 2 over square root of 3. Now we can do the work. Now we just have such smaller numbers to deal with, and makes our lives so much easier. So you multiply across square root of 6. And again, we should know that square root of 3 times square root of 3 is just 3. And I cannot cross these off and say square root of 2 is my answer, because they're different types of numbers. I just also want to point out before I let you guys do number 3 by yourself, this can also be written as this. So make sure you guys are understanding they're the exact same thing. If you have the square root of like an entire fraction, just one huge square root symbol, these mean the exact same thing. So you might see it written several ways on ALEKS or textbook. So make sure you guys are understanding that. So pause, do number 3 by yourself, and return back for your answer. Number 3, you should get, so I wanted to show you guys here again, you should get square root of 15 over 3 as your final answer. All right, almost there. So next one is just simply distributing. I don't think you're gonna have too much of an issue here, but it pops up from time to time with you guys struggling. So you just distribute as you normally would. So this would be 4 rad 3, because you have an inside and outside number. Square root of 3 times square root of 2 is 6. And we cannot add those together because they're different numbers on the inside of the radical. Okay, I'll do number 2. Distribute, so square root of 21 plus 9 rad 7. Again, I can't do anything because they're not the same, or I can't even break it down. So if I do like, oh, okay, 21 is 3 and 7, there's no friends, I can't break it down. I know a lot of you guys like want to, because 21 and 7 sound like you can factor something out. There's nothing to do here, so make sure you guys know that. So I'll just do one more because these are a little simple. So square root of 14 plus 4 rad 2. All right, lastly, we're just going to simplify quotients. And it's pretty much the same thing that we were doing earlier with simplifying. So I want you to simplify your radicals first. So I'm going to do it actually to the side so we don't make messy work. So 2 and 16, 4 and 4. So simplify, I could rewrite this problem as 4 rad 2 plus 14 all over 2. So here's where we need to remember our lessons on how we simplify fractions. So what we need to do here, if there's a plus sign here, you guys need to relearn this lesson because a lot of you make mistakes with it. If there's something on the bottom and it could go to all the terms on the top, then you're allowed to simplify. So for example, 2 goes into 4 twice, 2 goes into 14 7 times. You would not be able to do that if, for example, this 14 instead was like 15. Okay, we wouldn't be able to simplify because you can only do it to one of the numbers on top. You have to be able to do it to everything on top in order to go on to this next step. So if both 4 and 14 were not divisible by 2, we would not be able to move on. Okay, so then we just simplify. So obviously there's a 1 left over on the bottom. So your answer is 2 rad 2 plus 7. And obviously we don't have to say over 1 because we do not need to. Number 2, so we simplify square root of 72 first. So 2 and 36, 6 and 6. So we have 6 rad 2 minus 4 all over 2. Then we are able to simplify. Well, we check to see if we're simplified. If 6 and 4 are both divisible by the denominator, not either one, if both are, then you're allowed to simplify. So 2 goes into 6, 2 goes into 4, and then we are ready to write our answer. 3 rad 2. We don't touch the radical because it's an inside number, and that is our final answer. All right, one more. So square root of 18, 2 and 9, 3 and 3. So 3 rad 2 minus 18 all over 2. So 2 would have to go into 3 and 18 in order for me to simplify. We know this is not able to, so this is just your final answer. We're done. I'll show you guys another way this could potentially be written that would be correct, but I would think that most of us would just leave it like this, and this would be an acceptable answer. You might see it like this. So if you have a problem like this and you want to simplify it more, you treat this as one fraction, and then you treat, for example, this as one fraction. So, for example, that first one, that red one, so 3 rad 2 over 2, I can't simplify this. We're done here. But with the other second fraction, negative 18 divided by 2 is negative 9. So technically you can just simplify a portion of it, but I would just think that most of math teachers would just want you to keep this like this. But either ones, if you like the bottom one, go for it. Just know that you guys need to simplify it either way. So try number 4 by yourself, and then we're going to be all done. So number 4, square root of 2 minus 4 as your final. All right, now you guys are ready to continue on with your course readiness topics.